the next central quantity is the value function. So let's really try and unpack this a little bit. So the value function is a prediction of expected future reward. So why do we need this? Well, we need this to say, if you want to choose between state 1 and state 2, or between action 1 and action 2, how do you choose between them? Well, we want to be able to choose on the correct basis, and the basis that we're trying to use here is how much total reward we expect to get in the future. So the expected future total reward is what we mean by a value function. So formally, we typically write it something like this. So this would be a value function, and the value function depends on the way in which you're behaving. So we have to index it by pi here. So if I was to have a robot which is falling over a lot, that robot will get a very different total reward to an agent which is standing up or walking effectively. So the amount of reward that we get depends on the policy. And so the value function for a policy tells us how much total reward we expect to get going into the future. So we're going to look at the expectation over the future of the reward at time t, plus the reward at the next time step, plus the reward at the next time step. And we can also have this discounting going into the future. This is something that says we care more about immediate rewards than later rewards. So we'll understand this in more detail next lecture, but just to give you some intuition, this is a really central idea that we care about basically how much total reward we can get from some state onwards if we're going to follow this particular behavior. If I'm in my helicopter and I know that I'm going to execute some particular trajectory, how much reward will that trajectory get me? That's what we're trying to say here. And if we can compare these things, then we've got the basis to make good decisions, because we know which of those, should we choose the trajectory that's going to get us 73 points of reward in total, or should I choose the trajectory that's going to get me 65 points of reward? Well, it's obvious when you say it like that. So the value function is a really helpful quantity for optimizing behavior. Okay, so I'm just going to do one more video just to make this idea a bit more So this is the value function in Atari. So what we're looking at here on the top right, if we look at the top right, is exactly this quantity V that we were just talking about, saying how much reward the agent thinks it's going to get going into the future. And the one down the bottom is saying how much reward it thinks it's going to get for each different action. Just back up a little bit. And what you'll notice is that there's this sort of oscillating behavior where each time the bat is getting, each time it hits the ball, it was going to get more reward. Let me just back up a second. We can look at that. Here. So each time the ball is getting closer to hitting something, it knows it's just about to get this reward. There's no uncertainty left. And so it gets this big spikes in the reward according to this. And each time the ball's coming back down, the predicted future reward is going down. And so you get this sort of oscillating behavior. And it's only when the agent's actually close that it matters which way it goes. It has to make a decision when the ball's coming down of whether to go right or left. And until it gets right there, it doesn't really matter which one it chooses. Now for Space Invaders, what we see here, let me just back up again, is that what we see is that there's basically, we'll see a big spike, which is when the mothership starts coming along the top, it realizes that mothership might mean a big spike in possible reward it's about to get. Like if it actually shoots that mothership, it should expect to get a very large positive reward. And so when that appears in its state, when it starts to see this thing, its prediction of future reward should go up. And so that's what we see, is that now this mothership comes up, the value function starts to climb, it misses the opportunity to get it, and the value function goes back down again. Now we see another example. The value function is kind of flat, it's getting all of these things as it's shooting. Here comes the mothership. This time it shoots it, and the value function still goes back down, because we're always just talking about the future reward. The value function is how much reward we expect to get in the future. So the fact that we've just got that reward, so now we've received that reward, but we still predict that we're going to get less reward from now on, because the mothership's already come, we've shot it, it's probably not going to come again for a while. Okay, so we've got like this agent's internal measure of how much reward, how much score it's going to get going into the future from here. And this thing is like its oscilloscope of how well it's doing at any given moment in time. So it can be used to make decisions. Yeah.
So this reward is predicted in, let's say, 1 second, right? It's not predicting the end of the game, or just
Yeah, the reward has a time scale to it, and the time scale, if we just go back to the the time scale. So the question was, is there a time scale to how far ahead we look in? Is there a horizon to how far ahead we look into the future for these scores? And the answer is that the horizon is given by this discount factor. So at every step we discount the reward a little bit more and a little bit more and a little bit more going into the future until essentially we don't care about things very far into the future. So for that particular example, it was about 0.99, the discounting, which means that we're essentially looking, say 100 steps into the future. Yeah.
Is there some sort of a risk-reward trade-off between the value functions? So, for example, you care about value functions which have a lower expectation but are more stable in terms of actions you do.
Okay, so the question is there some kind of risk trade-off that you can make where you can, for example, can you balance variance of these reward predictions? The answer is that ultimately what we care about, we've defined a formalism in which what we care about is just the amount of reward we get, and if you care about just expected reward, then risk is already factored in, that you will figure out the behavior which correctly balances risk automatically if you optimize for this. However, there are people who specifically try to do, for example, trading, who take account of risk, and there's risk-sensitive markup decision processes which do try to explicitly account for this. So if you really want to bring in risk, you can, but I think the right way to think of this is that risk is already accounted for, that it will automatically, the behavior that maximizes value is the one that correctly trades off the agent's risks so as to get the maximum amount of reward going into the future. And that just automatically emerges from the formalism.